Wow, guys, this is crazy. MikroTik's really upped their game on releasing updates for their new version because for version 7.1, they've actually released two new versions today on the 21st of December, namely version 7.1.1 as well as version 7.2 release candidate 1. Both of these versions have various different changes on them, but they do focus a lot on the dynamic routing protocols, especially OSPF, and everything is looking a lot better on MikroTik. So I'm enjoying this, and I'd love to show you just how to quickly configure a very basic OSPF network on MikroTik version 7 so that you can maybe play around with it in your own lab. So let's have fun and let's get into the video. Alright, so I'm on the MikroTik webpage, and from here we can actually see that version 7.1.1 stable has been released, as well as the 7.2 RC1 test environment. And you could also look at those updates on your package manager. So if you haven't upgraded yet, you can use the upgrade channel to get to 7.1, or you can look at the stable version if you are on 7.1 to get to 7.1.1, or you could go to the testing channel to get 7.2 RC1. Please be advised that the testing channel does have quite a bit of bugs still in it, so just don't use that in production. That's more for testing and labbing and seeing what's happening. But the stable version is looking really a lot better now. They've implemented a lot of extra changes. I want to go to the changelog quickly because they've added functionality to the backup, so it's easier to downgrade back to version 6 if you don't like version 7 for whatever reason. They've also made some improvements to the BGP on IPv6, but the biggest stuff that I've seen that they've done is the OSPF. So they've done a lot of stuff for the OSPF to just make it a lot more stable and just make it work a little bit better. It was already working, but this is just more stability, and it's just there are some minor bugs that they did fix that I think a lot of people will be happy with, and it might make their OSPF networks a lot more stable. All right, so this is for 7.1.1. I just want to show you all of the changes on 7.2. And it should be this one. So let's just look at this changelog. Look at this one. It's crazy. So you can see they've definitely been working on a lot of changes for 7.2 and more OSPF stuff, more BGP stuff, a lot of winbox changes. There's a lot of extra changes. There's the Wi-Fi Wave 2 stuff. It's really starting to look like 7 is becoming a more predominant or a better version to look at upgrading to. If you haven't upgraded yet, that's good. You can still stick on version 6. It is still the actual more stable version, because for me, version 7 still pretty much feels a little bit like beta. They haven't changed the VRF spanning with BGP yet. That still doesn't work correctly. And also, there's still a lot of stuff that you can only do from the command line for whatever reason. And even if you work on the command line, it still feels a bit weirder, because you get all of these like forward like mark things whenever you type command. So if you tab something, you'll see what I'm talking about when we actually work on it. But let's quickly go into a lab which I've set up. I've actually got backup configurations already for all of the routers, but I did factory reset them so that we can quickly set them up and configure OSPF, so I can show you how OSPF works on version 7 now. So let's get into that. Okay, so here is my topology on EVE-NG. It looks pretty cool, but there's just a few things I've been playing around with version 7, and this is all version 7 cloud-hosted routers. The CPEs are all using 7.1. My provider edges are using 7.2, and my provider routers are using 7.1.1. So let's get into configuring OSPF. First things first, like I said, all of these routers have been factory reset, so I'm just quickly going to pause the video and configure just IP addresses and like a loopback address quickly. And when we configure the OSPF, I'll unpause the video. Alrighty, and we're back, and all I've done is add IP addresses between all of these devices as on the diagram, and we're just working on this ISP network. We're not touching anything on the CPs. So we'll be configuring OSPF, which is an interior gateway protocol. I do have another video on the channel explaining it a bit more, but I might make a future video just going over OSPF again, just showing people exactly how everything works, what LSAs and LSUs and all that wonderful stuff is. Alrighty, so let's commence configuration of OSPF. And what we've got is we've got loopback addresses, which we're going to use as our router IDs as well. And our goal is for all of these devices to see each other and to be able to ping each other's loopback addresses. And maybe I'll show you as well how to just advertise your networks, redistribute routes, etc. So let's first start on a router. I'm going to do the first setup on Winbox because people are familiar with Winbox. They like Winbox. So let's just start there. So I've got my management network connected to this provider 5 RR, which stands for route reflector, but that's more of something we'll use for BGP later on. And we're just going to connect to this. Great. So I don't have any OSPF or anything configured now. This is pretty much just IP addresses, a name, and bridge. So, and ROM1. So let's quickly configure the OSPF by going to our routing. What we can do is go to our router ID. And what's nice is a router ID was dynamically created for 192.0.0.5 because the router picked up, we created a loopback address and it's got a IP address assigned to it. So it's just using that as its dynamic ID. But we can assign a static router ID as well if we want. We can give it any name that we want, but I'll just leave this as ID1. And then my actual ID will be 0.0.5, which is the loopback address of this router. And I'll set this for any dynamic ID, or I can just leave this blank as well. And I'm going to apply that. So that's going to be the ID that we can apply on our routing engine, on our routing protocols. So let's go into the actual OSPF now. And what you'll notice is there's no networks anymore, because usually what you do is you create an area and then you'd go to a networks tab, you'd add a network, and then you'd link that network to the area. That you don't do anymore. So how OSPF operates now is you get stuff called interface templates, and then within your interface templates you can actually do the networks that you want to advertise. But first things first, we want to actually create an instance, and this instance is going to be our backbone. It's going to run in area 0, which is going to be for our ISP network. So I'm just going to give this the name of backbone, and with the version you can select, is this version 2 or version 3, because as you see, the OSPF is in the routing, but if you use version 3, that means you're going to be working with IPv6 and your neighbors will be connecting over IPv6. Whereas with version 2, you're connecting on IPv4, which is the normal IPs that many people are comfortable and used to. Now what we'll do is we'll leave the VRF as main. Router ID, if you set this as main, it will just use the dynamic ID that the router has selected, or you can select the ID1, or you can specify it yourself if you'd like to. But I'll use ID1 because that's the router ID that we configured. And your routing table is, if you're using multiple VRFs, you can select that VRF, but we're going to leave this blank because then it will just select our main routing table. There's a lot of other stuff here, like the originate default, which will advertise the default route out to the rest of the network. So if you maybe have a router that's connecting to an internet peer and you want that default route to be advertised to all of your other routers, this is what you'd use the originate default for. And then with the redistribute, these are the type of routes that you want to advertise across the network. So this is pretty cool, and we will use this in a moment when we want to advertise some or redistribute some routes. Then you've got your filters. So if you're making use of route filters, you can actually specify the filters here just to maybe block certain routes or accept only certain routes. And in baseline, that's how we're going to set up OSPF. So I'm going to configure the backbone in version 2, and I'm just going to apply that. Then we're going to set up our interface template. Actually, we're going to set up an area first. And our area is going to be the backbone as well. The instance is backbone because that exists by default. Or, sorry, the instance is what... All right, so let's configure our area first. So let's create an area. Going to call this backbone, and the instance that we're selecting is the one that we just created, which was called the backbone. Our area ID is 0.0.0.0, which is the backbone ID for all OSPF routers. If you're using multiple areas, then you can use .1 or 254.0.0.0, whatever you feel comfortable with. But we're just leaving this as the default, and the type is also going to be default. We're not going to do stub or not so stubby areas. We're just using default in this demonstration. Apply this. And now that we've got an area, we can create an interface template. And with the template, we just hit the plus, And I'm not going to select any interfaces. I'm just going to leave that blank. The router can decide which interfaces it's going to add based off of the networks that we're going to add. And it's actually so quick and easy to set up. As you see, there's some authentication built in on OSPF now as well. This is actually quite nice. But let's select the networks that we want to broadcast out. So I'm going to broadcast out, firstly, our loopback address, which is 192.0.0.5. So if I go to my addresses, it's actually quite easy to see what I'm going to configure here. So my networks will be 192.0.0.5. Let's add another network by just hitting that down arrow. I'm going to advertise 10.0.10.0/30, 10.0.9.0/30, and then 8 and 7. So let me just copy paste quickly and just fill in, because this will save us some time. And you don't need to put it in order. As you can see, I put 7 and 8 like in a mix there. And now I can specify our network type as well. Is it broadcast? Is it point to multi-point? Is it point to point? So in my topology, this is actually going to be point to point, because the interfaces are connecting to a single router. So it's not like running to switch to multiple routers or anything. So this is going to be a point to point, but I could leave it on broadcast and that could work as well. But let me set this for point to point, and that's about it. That's all I really need to do. So we've configured OSPF on the route reflector, or this router on the middle. Now we actually need to set it up on all of the other routers before it actually really works and effectively works. So I'm going to do another router on winbox, and then we're going to do the command line as well. But what I want you to see is with the interfaces. So after I specified the interface template with my networks, it's picked up which interfaces is going to be running the OSPF on, and it's actually trying to get neighbors, and it's doing link state announcements and stuff already. Okay, so let's configure another neighbor that's actually connected to this router so that we can see what's happening. So I'm just going to open up another winbox session, connect onto Ramon, then I'm going to connect to this P1 router. And then on P1, it's actually going to be nice, quick and easy, because we're not going to worry too much about discussing all the details now. So I'm just going to add a router ID, 192.0.0.1. And I'm just going to go into my routing, go into my OSPF, add an instance, call it backbone. It's version 2. And we're just going to set our router ID. And I'm going to add an area, call it the backbone. Go into my interface templates, and then let's add our networks. So this is 192.0.0.1. And let me just see what networks we have here. So we've got 10.0.0, 10.0.1, and 10.0.7. So let's start with 10.0.0.0/30. And I'm just going to copy paste quickly and edit where we need to, and change the network type to point to multi-point, or point to point, excuse me. And that's it. So I'm going to apply this, and then let's just first see if the proof is in the pudding. Let's see if our neighbor actually establishes, and it has. It's gone into a full state. We can see it's connected to that neighbor, and this is freaking awesome. I really love how quick that was. That was actually super fast. Okay, so let's configure the rest of the network on command line, because that's actually going to be relatively quickly or faster for me. So I'm just going to jump onto the P2 router, go into command line, and then I'll show you how to do this via the command line. But after this router, I'm just quickly going to configure the other routers and pause the video. And then once everything is up and running, then we'll do some tests and see how we're learning routes. All right, so first things first, we're going to go into the routing, and then I can do an ID. I can add an ID, I can give it a name. It was ID1 by default, and we want to just set an ID. So in my case, this will be 192.0.0.2, which is the loopback address of provider 2. Then I'm going to go into routing, OSPF. I'm firstly going to add an instance. So let's add an instance, give it the name of backbone. We're going to set the version to 2, but it should be 2 by default. We're going to set the router ID as id-1. And I actually think that's all I need for the instance. So let's add our instance. Then we're going to go routing OSPF area, because we need to add an area. We're going to add, and then we're just going to set our instance to the backbone, which we just created. And we're actually not going to touch anything else. We can give it the name as well of backbone, but we don't need to tweak anything else. And then we're going to do routing OSPF interface dash template. So this is where we configure our networks and such now. So what we're going to add is we're going to set our area as the backbone. We're going to set our type as PTP. We're going to set our neighbors or networks. And this is actually quite fun to do. So all that we're going to do is the networks. We're going to say 192.0.0.2, and then we can make a comma. Sorry, the screen looks a bit weird right now, but this is something I've picked up with Router OS version 7.1 on CHRs. So if I run into some configuration, it's still doing the config, it's just adding, as you can see, like a bunch of lines. All right, so what else I want to add is the actual /30 addresses. So that is 0, 8, and 2. Okay, so that's actually quite easy to remember. So 10.0.0.0/30, 10.0.2.0/30, and 10.8.0/30. I'm going to hit enter, and then I'm just going to do a routing OSPF interface dash template. I'm going to just print this so you can actually see the configuration properly, because all you need to see is I've added my area as the backbone. I've added my networks, which will then dynamically create the interfaces that I want to participate in OSPF, and these are also the networks that will be advertised out across the network. My type is point to point, and that is all that I've actually changed now. So let's quickly see if I do a routing OSPF neighbor print. I can actually see I've got two neighbors, both of them are full. And if I do OSPF LSAs, let's just look at our LSAs that we're receiving. Awesome. So now we can actually see what type of networks we're learning as well. And if I just do an IP route print, this will also actually show us which routes we're learning via OSPF. So we've already learned 192.0.0.1 and 192.0.0.5. Awesome. Okay, so what I'm going to do now is just quickly configure the rest of the OSPF on all of the other routers, and then we're going to look at just doing stuff like redistribute. So be right back. All right, I'm back, and this is the last router we just need to configure OSPF on, and I just want to show you how quick OSPF is if you know exactly what's going where. So all I'm going to do is type routing OSPF instance add name backbone routing OSPF area add name backbone instance backbone routing OSPF interface dash template add. Our area is backbone, our type is PTP, and now we just fill in our networks, which is 192.0.0.7 and 10.0.6 and 2. 2.0/30, 10.0.6.0/30. Enter. And that that was so quick. 3 quick commands. I didn't specify any IDs or do anything fancy. I just used some very basic configuration. And if I do a routing OSPF interface print, we can see which interfaces are participating in OSPF now. So Ether 1 and 2 practically. And if we do a routing OSPF neighbor print, we can see we've got 2 neighbors on PE2, which is correct because PE2 connects to P4 and P2 as neighbors. So the router we'll get the most information out of is P5, which we were connected on via winbox. So let's just go back on winbox. And if I look at my neighbors, I've got 4 neighborships from P5. And if I look at my routing table, it's actually being populated with quite a bit of routes now. and we are learning all of the loopback addresses for our OSPF. That's actually pretty cool. And you'll notice there is something like a DAO plus, and that DAO plus is just telling you it is dynamic, it's active, it's being learned from OSPF, and the plus is actually like ECMP. It's telling you there's multiple paths to get to that route. So this is pretty awesome. We've set up the OSPF. So let's test and see if it's actually working. So what I want to do is from PE1, which will be 192.0.0.6, I want to see across my network, can I get to PE2, which is 192.0.0.7. So let's test this out by just logging into PE1. And we're just going to do something as simple as a ping. So ping 192.0.0.7. And we can source it as well if we want to from 192.0.0.6. Let's see. And we've got access. So routing is officially working from our 2 PE routers across the network. And if I do something like a trace route, let's see, tool, trace route, 192.0.0.7. We can specify the source as 192.0.0.6. We can actually see the hops that it's taking to get to that address. Awesome. So I know the OSPF is working. If I look at the routing table from here, we'll see we are also learning this route .7 across the network, and we know that this is working. Cool. So next up, let's just quickly talk about redistributing routes, because we don't essentially, maybe we don't always want to advertise all of the networks by going into that networks tab. Maybe we want to quickly advertise specific type of routes, and for that we'll use the redistribute function. So I'm going to just show you how to do this from winbox quickly. So I'll connect on to Ramon, and I'll connect onto the PE1. And then on PE1, there is actually routing configured currently, or there's a interface configured on Ether 10 for 172.29.0.0/30, which I'm not advertising via the OSPF because I didn't specify that network, but we can quickly advertise this by doing a redistribute, by going into the routing, going into the OSPF. I can go into my interface templates. Actually, I can go into my instance, and then from the instance, we can do the redistribute, and then I can just select redistribute connected. So all my connected routes, which is in this routing table, will then be advertised across the OSPF network. So let's just advertise the connected routes, and then we can very quickly see if that's working by going back onto PE2, and I'll go into this command line for PE2. And what we'll see is if I do an IP route print, I should see a route for 172.29.0.0/30. I'm not seeing that route at the moment, which is fairly interesting. I'm actually expecting to see that. Oh, it just took a minute. So the routing is being advertised now, and we can see 172.29.0.0/30, and it's got multiple paths. So this might also be a bit not nice if you have these two routes having the same cost. So you can definitely change stuff like the cost of links on the OSPF just to prefer a certain path across the network. But I'll make a detailed video on just OSPF explaining exactly how everything works. My goal was to explain that they've actually, I don't want to say completely fixed OSPF on version 7.1, but it's definitely looking good right now. It looks like you can actually advertise networks, connect all your neighbors, and everything should work fine. I've tested this quite extensively on CHRs and actual hardware as well, and I've been having a blast with OSPF. So I'm going to actually end off the video here. I'd like to thank you for watching. Please feel free to leave a comment. Let me know what stuff you'd like to see in future videos perhaps. I hope you have a wonderful day, evening, whatever time it is, and I'll catch you in the next video. See ya.